Understand, in this particular question, there is a conducting spherical shell with inner radius r1, outer radius r2. So this is a conducting spherical shell. Inner radius r1, outer radius r2. Has a total charge of minus 2q placed on it. So this whole thing, like, let me just tell you this way. If this surface is q1 and this surface is q2, then what we know is q1 plus q2 is minus 2q. Do you understand this? What is the electric potential energy of this charge distribution? What is the electric potential energy of this charge distribution? This is it, right?
Minus 2q, is it given?
It is given. It is given. What? Those are inner and outer surfaces of a conducting spherical shell. So it's like this. There is a void. Okay. So can you tell me what is Q1?
0.
Ali says 0.
There isn't something inside, right?
There isn't anything inside yet. So it is?
What do you mean by inside?
There's nothing else. Like Q1 plus Q2 is minus 2Q. This is a conductor. So since it's a conductor,
It's a plus q on the center of the...
I think that's what is confusing you. In part A, it says just this and just asks for the energy. Was this what confused you, maybe? No.
Minus q.
Okay. Please pay attention, please. So what is the electric field over here? Electric field at this point? It's 0. Very good. Good reflexes. So E is 0, which means that Q1 is 0 because Q1 is Q enclosed. It has to be 0, which means that Q2 is minus 2Q. Okay? And this basically boils down to the problem that we just solved. It's just 1/2, whichever way you want to see it, 1/2 k q squared over r. And in this case, 2 minus 2q squared over r. That's it. That's the solution.
Energy?
Yes, the problem asks for the energy. And R is R2 because all charge is concentrated on R2. Is that the correct answer? Are you satisfied by this solution? You are not.
Hocam, which formula we use for you?
Which formula we have used?
Last of formula regarding to you. I have some questions.
Ve ben hangi formülü kullandığımı
No, the thing is that I really don't understand why we exactly using the potential energy formula. Like, this is not a point Q.
Yes, we are not using it exactly.
Yes.
There's a 1/2 in front of it,
Okay.
right?
Yes.
Where does 1/2 come from? It comes from this. It's exactly the same problem. Let's discuss this problem one more time. So I'm going to put charge Q on top of a conductor. How do I manage to do that? I don't just bring plus Q from infinity and just put it there. I can't do that, okay? I have to bring it one by one, okay? While I'm bringing it one by one, each time I put so far I have brought plus Q, okay? So each time I have plus Q, it gets harder and harder to put more.
Yeah.
That's why it's not, it's like a triangle. Underneath a triangle, you don't have the full area, you have the half of the area. Do you understand it? That's the thing.
Hocam 1/2 QV formula.
It is 1/2 QV, but be careful. It works here. There is no 1/2 QV formula anywhere else. Where did you see 1/2 QV?
In capacitors. No.
Yes, in capacitors also it was 1/2 Q.
There's no
Yes,
Q.
it is true.
Ah,
There is Q.
There is Q. I thought so.
It's the same. Yes, because in capacitors as well.
How did we use it here? I am confused.
Sen kapasitansa geliyor.
Let's go step by step. You asked me, is it 1/2 QV?
Mm-hmm.
Yes, for the capacitors, because capacitors also do it gradually. Like when you have Q and minus Q, it's harder and harder to take another dq from minus Q and put it to Q, right? Gets harder and harder. That's when you have 1/2 QV. You have Q times V. If V is always there, V is not changing, and you just take Q from here to here, then it's QV. But if it is the case that when you put charge more and more there, it linearly increases V, then you end up with QV/2. Let me give you an example. So let's say there is an F0 pulling me back, okay, and it will be too long, don't worry about it. It's the same thing with 1/2 kx0 squared. Do you remember for the harmonic oscillator energy? Because as the more you pull, the harder it is to pull further, right? If it's a constant force, then it's F times x. It's like a rectangle. If the force is linearly increasing, then it's kx0/2 times. Okay. So here's the thing. In a spring, you take it like this, right? So this is kx0, this is x0. What is the area? Kx0 squared over 2, right? But if you did it this way, where the force would be constant, which is not the case when you have a spring, right?
Yes.
Okay, then you would have kx0 squared, just that. And that is not the spring case. Okay? So what happens here? I have 0 charge. I put a little bit of charge here. Let's say I make it Q. And the higher the Q, the more harder to put further Q, dq on top of it. Okay? That's why you can think of it this way. Q is equal to C times V, right? So V is equal to Q/C. So this is Q. This is also Q. This is V, which is equal to Q/C. This is Q. So it goes on like this. So you reach at Q0/C, and here it is Q0. And what is this area? Q0/C times Q0/2. Do you see it? Are you happy? Good. All right. There is a very not so easy question that you asked me, and I will solve it anyways. Okay?
Hocam, It's
Wha-
battery charging, right?
It's battery charging. Very good. Very good. When you have
Show it.
when you have battery and you charge the battery keeps being at the same voltage. Yes. This is the battery case. Very good. So this here is a question, and please appreciate my improvisational skills here, that I'm seeing the question for the first time. Right? So this is distance A. This is also A. This is 3A over 2, meaning that this distance is also A. Right?
Tam ortasında
Tam
oldu.
ortasından. The center of the rod is at a distance 3A over 2. Calculate the electric force on the rod. Okay? So this is plus Q. This is plus Q. Okay, do you have any questions? So, I will construct the integral, and if it's a ridiculous integral, I will not bother taking it. Okay? And you also construct the integral. If you think that it's ridiculously hard, just leave it like that. You should lose very little points. If you have a clean sheet, like this is integral, and I think you can say, I think it's ridiculous. And we will grade your taste in integrals accordingly. Okay? So, good. Now, why do we need integral here? Did I tell you this question? Calculate the electric force on the rod. So, it is a ring. So it's a bit easier. Our life is a bit easier in a sense that I can take a distance x here. And at this distance x, there is dx here that has a dq. Can I just make, okay. Let me make this one Q0, this one Q0, so that I don't get mixed up with the integrals and boundaries and stuff like that. Okay, so what is the force on this tiny bit of charge here? What we can do is we can find the electric field. Exactly. So dF is dq times Ex. Do you agree with this? So what is Ex? K Q0
Times cosine of the angle.
There's no what?
Like theta, like we should take the cosine.
Yes, we should take the cosine.
There is no given theta.
We don't need theta. We can just write. We can just write x over 3/2 of this. Okay? Are you with me?
Yes.
Yes? Good. It turns out it's not a ridiculous integral. Okay? So dq is q0 over a times dx, right? Why it's not a ridiculous integral? Because df is equal to k q0 x, and then there's q0 dx over a x squared plus a squared 3/2. It is not ridiculous because I have this x dx already here. staring at me. So it just screams at my face,
U substitution.
U substitution. Right? So I do the U substitution and the screams fade away. What do I get? K Q0 over 2a du over u to the 3 halves integral, right? We will come to the boundaries. Don't worry about that. So what is the u to the minus 3 halves integral is u to the minus 1 half divided by minus 1 half, right? So it's minus 1 over square root u. K Q0 over a 1 over square root u. I took it away with this 2. Okay? This is with a minus sign. And I can actually evaluate. Okay. K Q0 over a minus 1 over x squared plus a squared evaluated at a and 2a. Do you agree?
Can you explain boundaries?
Sure. Just one moment. 1 over a square root 2 minus 1 over a square root 5, I guess. Just check the algebra, but the boundaries go from a to 2a. This is x, so I defined it with respect to this center. So the material starts over here, so from a to 2a. That's why when I put 2a, I get, when I put 2a, I get 4a squared. So 4 plus 1 is 5. A square root 5, and that's it. Are you happy?
Hocam, eksi aslında integralle bulduk ama o stepi atladınız siz değil mi?
Not really, because it's sort of in between taking and not taking the integral. Do you remember the very first? Yes. The thing is that the charges are always at the same distance.
If it would be disk, then we wouldn't do that, right?
If it would be disk, we wouldn't do that. Any other questions?
Can you explain how you found
Can I explain how we found
DQ?
dq? Yes, of course. So, what is the density, charge density here? For every a, you have q0, right? For every dx, you have dq. So if you do cross multiplication, a times dq is q0 times dx, which tells you that dq is q0 over a times dx. Any other questions? No? Are you happy? Yes, I'm happy too. So no reason to go to weird integrals in this particular question. I have so many questions that I can solve. Yes. Okay. Just to tell you that it's not all about integrals. You could have such a question, for example, which just tests your
question would be find the total electric potential energy of the system.
No. That we did too many times. This one is for, actually, let's find the total electric potential energy first. Okay? Then we move to the question. So what is the total electric energy potential of this system? Do you understand the question? Yes. What is the total electric potential energy of this system?
There is 6 different calculations.
Yes, exactly. There is this one which cancels out with this one, right? This one cancels out with this one, right? So 0 from them, right? But this one and this one does not cancel out, and it's just 2 times k q squared over a square root 2. That's the total energy. Did you follow? It is minus. Very good. Very good. So this structure is stable. This structure actually minimizes its energy. It will not, like if you release it, it will actually squeeze down, not go to infinity. Any questions? No? No, right? Do you understand this part? So can you find the electric field in the midpoint?
Midpoint. 0.
Electric field is 0?
In the midpoint.
In the midpoint, yes. Is it
By
0?
Gauss,
Okay. Did you just say it, or did you just say by Gauss, or did I misheard it?
I say in the midpoint, isn't Q enclosed 0?
Okay, good, very good. So Q enclosed is 0, but we don't have the symmetries, right? So you can't use Gauss law here. It is going to be Q enclosed is 0, so the E dot dA integral will be 0, but it doesn't mean that electric field will be 0 there. Okay?
Can I ask something? Hocam, regarding what Kemal just said. Hocam, in some questions in previous exams, the solver assumes some kind of cylindrical shell between the charges. And so they said we can apply Gauss law in that kind of question. So what's the trick point? In which cases we can create arbitrary cylinder or arbitrary enclosed space, and in which case we cannot?
So you can use cylinders when you have an infinite wire or infinite cylinders. That's when you can use cylinders. You can also use cylinders, but in a different orientation, when you have infinite sheets, right? But otherwise, the other possibility is to have a spherical symmetry where you have spherical surfaces. And that's it. Just watch this video, Gauss's law, okay? And the video after that one, which is application of Gauss's law. And all possibilities are covered there, okay? So for this particular one, we have to go step by step, okay? We need to find electric field due to this charge, let's say, is pointing in this direction. Due to this charge, it's pointing in this direction. Due to this one over here, which way is it? It's also pointing in this direction, right? And this one is also pointing in this direction. Do you have any problem with this? No. All of these are the same magnitude, right? No x component will be there, right? The magnitudes, let me call one of them E. That E is basically k q over r squared, which is a squared times 2. No,
A root 2 over 2.
2a squared.
a squared over 2.
Okay.
Do you agree? Because this is a over 2, this is a over 2, this is a over a root 2 over 2,
So 1 karesi.
and the square of a root 2 over 2 is a squared over 2.
Okay.
Do you agree?
Yes.
Why are you laughing?
Nothing hocam.
Something happened.
Sizin sabrınıza çok hoşuma gitti.
What?
Sizin sabrınız çok hoşuma gidiyor hocam.
Hani bize anlattınız ya basit
Yok
işte.
estağfurullah. Sorduğum alakası yok. Deminden beri hep anlatıyorsunuz diyor hocam. Çok hep güler yüzler ha o yüzden yani.
Oh, okay. Thank you. So, I have electric field here, another electric field here. So 2e there, 2e here, and they are 45. So 90 degrees. They come together. It's 2 square root 2e. So I'm going to have e total pointing down, and the magnitude will be 2e2, 2 square root 2e, which is 4 square root 2 kq over a squared. The tragedy with this problem is that there's no integral, no nothing, but you can do lots and lots of mistakes here, right? Was it a over 2? Was it a square root 2? Did you take squares? Did you take cubes? I mean, yes.
Hocam, I'm just only confused about the electrical potential energy.
Yes, let me come back to that.
Sorry for that yani. Öyle şey,
You shouldn't be.
olmuyor bazen.
Estağfurullah. So, this one, right?
Evet hocam.
Yes, no worries at all. So, what was your name?
Volkan hocam.
Volkan.
Volkan hocam.
Okan.
Evet.
Okan, look. I have four interactions here. Do you agree?
Yes hocam. Sure.
And I have 2 more here. Right? So, I said that this interaction, the energy from this one, will cancel the energy from this one. Why? Because the energy from this one is kq squared over a squared, but the energy from this one is minus kq squared over a squared. Why minus? Because this is plus plus, this is plus minus.
They are attracting each other. Right?
This one is attracting, and attracting stuff has negative energies. These ones are repulsive, and repulsive stuff has positive energies.
Okay. So we have only the mid.
You have only the mid parts. And coming, okay, I made a mistake and you are not correcting me. What is my mistake?
I think it should be J hat. Is that
Yes, that's another mistake that I made. But I wrote here kq squared over a squared.
should be A.
It should be just a. Do you see it?
Sistemi serbest bıraksak daire çizerek ortaya mı çıkar?
The question is what happens if we release this system? And let me think about it. Seems like at the beginning they want to go this way, right? This way, and then they come together somewhere there.
In the middle. Değil mi?
Ama diğeri de zıplayın gibi görünüyor.
What?
Zıplayın gibi görünüyor mu? Yani sanki daire çiziyorlarmış gibi olmuyor mu?
I don't think there will be a circular motion here, but I'm also not sure. We will get circular motions if you like them when you have magnetic field. So wait until we come there. Yes. Yes, yes, yes. You should. Let's do projectile motion. Okay. No. Just I'm going to ask a question which has projectile motion in it. Is it okay?
Projectile emission what does it mean?
Eğik atış.
Öyle proje.
So that's a good question. Will it be in the midterm? In principle, you should know 101.
Yes, but we can take 102 before 101. So
Yes, yes.
I don't think we should know.
Yes, like if I ask you this kind of a question, will you be able to solve it? I have an electric field, uniform electric field in this direction. I have a charge plus Q. No. I have an electron. I throw the electron in this direction with angle theta. First, describe the motion. So it starts with V0. What kind of a motion do you have? You have projectile motion like this, right? The plates have charge that create, let's say it has plus Q here, minus Q here, and it creates uniform electric field. So uniform electric field creates sort of a gravitational pull downstairs. And for example, can you find x here, the distance x? Will you be able to find it?
Yes.
If you think hard enough, right?
Will we think about also gravity and
No, no. You already asked this.
yes.
You remember. So if you think about gravity, it will be 10 to the 20 times smaller. So you don't need to consider it. But instead of gravity, you can use just, instead of G, you can use G as E times E over ME. That will be the gravity of this system. The acceleration of this system will be F divided by M. And the rest is whatever you remember from projectile motion, or whatever you don't remember, which is this. The time it takes will be 2 V0 times sine theta over G times V0 times cosine theta. And in terms of G, it is just E over M. So it will be 2 M V0 E V0 squared. Actually, it will be just sine 2 theta. Don't get intimidated. Just like remember this kind of simple stuff, okay?
We don't even need to memorize this. We will solve for t with the vertical components, and we will just substitute the t
Yes,
value we found
yes.
in the x component
Exactly.
equation.
Let me ask you this question. Yes. Quiz? You want quiz?
No, I mean.
It's not.
We
It's
said we are going to do it.
okay. Should we wait for the music to kick in?
Bir dakika erken başlasak hocam güzel olur bence.
Okay, I'm starting.